Hello, virtual GED students. We are back after our month hiatus, and I am so excited for today's lesson. I feel like a really big slacker because I haven't taught this so far, because this is probably the most crucial lesson in all of mathematics that I teach. And I don't know why I put off doing it so long with my virtual GED students, because it's usually the very first lesson that I teach to any new student coming into a GED class. We're going to talk about the basic operations. Now, a lot of students get mad at me during this lesson. Kate, why are we talking about the basic operations? I've been doing that since elementary school. I don't need your help with that. And I say, if you understood some really crucial things you're supposed to understand about the basic operations, you wouldn't be making the mistakes in algebra that I see you making. Okay, math is math is math. I don't care if you're working with whole numbers like we did in second grade, you're working with fractions like we started doing in third and fourth grade, decimals, negatives, algebraic expressions, whatever kinds of numbers you're working with, the basic operations are going to guide how we work. So what am I talking about? What is Kate talking about? First of all, the word operation. We've got David with us here today. David, do you know what I mean when I say operation in a math class?
No.
Okay, well, there you go. That's the place to start, huh? Operations are the things we do with numbers. So, you know, on the very first day of math class, probably way back in first grade, your teacher said to you something like, if Jimmy has 3 candies and Tommy has 5 candies, how many candies do they have total? And you did some math to find that answer. What operation am I talking about there?
Adding.
Exactly. So addition is a great example of an operation, okay? Then once you learn to add, your teacher had you say, well, you know, if we could put candies together, there must be a way to take them back apart. So we learned the opposite of addition, which is?
Subtraction.
Exactly right. Then one day your teacher had to recognize that sometimes there's a faster way to go. You know, she said, well, what if everybody in the class had the same number of candies? What if they each had 5 candies and we've got 30 students and we wanted to put them all together? So what would we be doing in that case?
Multiplication.
Exactly. And of course, once you learn to multiply, you could learn to do multiplications opposite. You could learn to take a total and break it into equal sized groups. I'd be talking about
Division.
Exactly. So those are the 4 basic operations. Those are not the only operations on the GED, but those are the ones that come up most often. And these are the ones that really stump students who struggle with word problems as well as in algebra. And since the 2 biggest skills on the GED are word problems and algebra, we've got to cover this topic, okay? So go ahead, do me a favor, take your notebook, break it into 4 sections and title them for me: addition, subtraction, multiplication, and division. Now my tablet's pretty small. I'm going to try to squeeze in everything I need here, but I hope you have a nice big piece of paper to write on, because we're going to be talking about a few different things with these numbers. Okay, I want to talk about symbols. What do those look like mathematically? I want to talk about language, the official terminology we use, and I want to talk about what it means. And so that's going to help us relate what we're doing here to algebra, interpreting word problems. Okay, so let's start with symbols because that's the easiest way to go. Most people know what symbol we use to signify addition in math class. I bet you won't be surprised to know that it's that plus symbol. Looks like a little cross. I've never had a student yet who didn't know that that was the mathematical symbol for the addition operation, but I'm about to teach you a new word, okay? So the only reason I'm teaching you this probably won't show up on the GED is because math teachers use it, I use it, I want you to know what I'm talking about. That is the operand for addition. It is the symbol that tells you to add. It's the operand. You can see operand is like the same root as operation. The operand is the symbol that tells you the operation. Does that make sense?
Yeah.
Okay, cool. So we know the operand for addition. Do you know the operand for subtraction?
The negative sign.
Yeah, the little minus sign. Interesting that you called it the negative sign, because sometimes it's a negative and sometimes it's a minus. With addition and subtraction, it's super straightforward. We only have those symbols. We only use those symbols. I've been doing math for a really long time, and I can't think of another way that a mathematician might write addition or subtraction. However, that is not true of multiplication and division. They are more complex. So unfortunately, you know, we teach you this little time sign. We have you use it up until about 6th grade, and then it gets totally and completely dropped. I will be very surprised if you see the times sign even once on your GED. In fact, if you do see it, it'll be in the first 5 problems where you don't have the calculator. But after that, once again, in word problems and in algebra, you will not see it at all. What will you see instead?
Probably a little dot.
Yeah, a little dot is one of the ways that we talk about multiplication. Now, be really careful. If I wanted to tell you to multiply, no, I'll put 3 times 5 here. If I wanted to tell you to multiply 3 times 5, that dot can't be down there on the ground. If it's down there on the ground, I think that you're talking about 3.5.
Mm-hmm.
So if I want 3 times 5, that little dot would be floating in the middle. Very frequently, they will use a dot or even a star. And those two symbols are brought to us by computer programming and the fact that we live in a digital age. They're very typical of computers, but they're still not the ones we use most common in algebra. In algebra, we don't even use the dot or the star as much as another way of saying multiplication. Have you ever seen another way to multiply, David? I bet you have.
Parentheses.
Parentheses. Now, I need to qualify that because every student I've ever met has told me parentheses mean multiply, and I say, well, not exactly. Let me show you what I mean. You don't have to write this down. I'm about to erase it. Okay, here are different mathematical expressions. Now, you guys might call those a math problem. I call them an expression. And it's important that you can use math language to understand the GED. So here are 4 different mathematical expressions. All 3 of them have parentheses, but in only one of them are the parentheses telling me to multiply. Do you know which one the parentheses are telling me to multiply in, David?
2, 3 plus 5.
Yes, this is the only one where the parentheses are telling me to multiply. Now, those are very complex expressions that I wrote. I don't need you to panic. I don't know what to do. I'm not asking you to do anything. All I'm asking you to do is that recognize that this is multiplication when the others aren't. Now, how can I tell? What you're going to notice here is that the only thing between 2 numbers in this case are parentheses. So it's not just the parentheses, it's parentheses with what I call proximity. Parentheses with proximity. When the only thing between 2 numbers is parentheses, that's when you know you're multiplying. Now, if you look in this case, you know, not necessarily the case. I got this minus sign between. I would think of that as a different way. And of course, in this problem here, I have something entirely else going on. I have a power, which we're going to look at in the next video. So let me go ahead and erase this and show you what how a mathematician would write parentheses with proximity. Okay? So if I wanted to say 3 times 5, I could write that a couple different ways. I could write 3 and only the 5 is in parentheses. But again, you're going to notice that those 2 things are in proximity. They're super duper close. They're almost touching. The only thing between the 3 and the 5 is the parentheses. Therefore, it's multiplication. And it could be that both the numbers are in parentheses as well. But what I want to point out to you that it's not really the parentheses that are telling us to multiply. It's the proximity. The only reason that I use parentheses is because of this. Imagine if I wrote 3 and 5 really, really close like that. Does that mean 3 times 5?
No, that's 35.
No, that says 35. So the parentheses are just there so you see that one's a 3 and one's a 5. It's the proximity telling us to multiply. Does that make sense, David?
Yeah.
Okay, cool. So then it should make sense then that when a mathematician talks about a number and a variable multiplying an unknown number, they will just shove the 2 really, really close together. Like, for example, if I wanted to say 3 times y, bingo, 3y is 3 times y. Proximity alone is enough to tell me to multiply. So David, nobody has to put this into their notes, but David's pretty advanced here. I just want to let you know if you saw something like this on the GED test, right there, those 2 things are shoved together, 3 and the square root of 25. I don't have any parentheses there, but I got proximity. That's 3 times the square root of 25. Another example here, I have -3 shoved up against the absolute value of -8. I do not need to know how to do this problem to see that those two things are in close proximity. There is multiplication happening between those two things. Okay, so we now make sure we get that word in our notes. Proximity, closeness means multiplication. Similarly, division, we gave you a symbol way back in elementary school. And can you read that expression to me that I just wrote there, David? When I say an expression, I mean both the numbers and the operands. I want you to read the whole thing.
15 divided by 3.
Very nice. I'm super glad that you said divided by. Now, way back in elementary school, when we didn't know how to divide by, your teacher would have you do some scratch work. You know, and when we do our scratch work, we would use a different symbol. That guy doesn't even have a name, by the way. He's not an official symbol. Math, math students think that that little division house or whatever you want to call it is like some math symbol. No, it's a way of organizing your scratch work for long division, okay? But what I want to point out to you is when we wrote it this way, we did not read this problem the same way. This does not say 3 divided by 15. Do you know what this says?
15 divided by 3.
It is 15 divided by 3. It is equivalent to 15 divided by 3. However, if I were reading the 3 first, I would actually say divided into. So dividing into is different than dividing by. Okay, dividing into is how we would do our scratch work for long division. But this symbol up here is a divided by symbol. Okay, so the first one that you learned, and this is the one that mathematicians, we use dividing by when we write mathematical expressions. We will not use the divided into symbol at all, okay? So the only place this sucker belongs is in your scratch work. I don't even want to see that in your beautiful algebra, okie dokie. But we will use divided by signs. But unfortunately, just like with multiplication, I pretty much almost totally get rid of this symbol in algebra. I use a different symbol for divided by. Do you know what I use when I want to tell you to do 15 divided by 3?
You write 15 over 3.
That's right, I use a fraction bar. Now, students hate that because you guys have an irrational fear of fractions. No joke. I can make grown men cry by just saying the F word in class. But guys, let me point out 1,000,000 times over that all a fraction bar means is divide. It literally means 15 divided by 3. And I could do that division. 15 divided by 3, you know, that's 5. It's not a fraction anymore, okay? Fractions only get funky when I can't do the division. For example, 1 divided by 3 would not be pretty, so I would leave it as the fraction 1/3. That says 15 divided by 3, and this is the most common way we're going to see it in our algebra. Now, I do recognize that a lot of students have that lazy diagonal fraction bar. You guys like to write your fractions that way. I'm going to beg you not to. Not because you're wrong. Good news is you're totally right. I beg you not to because having worked with adults with disabilities as long as I have, I know that I could bring down your test score about 5 to 10% by just turning all the fraction bars like that. When your fraction bars are diagonal, your brain will have a lot harder time telling which number's on the top, which is on the bottom. You'll make a lot more errors. So save yourself the trouble, write them that way, and you'll make less errors in your math. Nice horizontal fraction bar. So we talked about the symbols. So let's move on then to 4 important words you need to know. They're very frequently used on the GED, and I will not be the least bit surprised when if you see one of these on your test at the end of the month, okay? The first word is the word sum. Now, I ask students what a sum is all the time, and students tell me sum is plus. And I kind of agree with you, but not exactly. Sum means a little more than just plus, okay? This is plus. It's just one little symbol, plus. A sum is talking about a whole math phrase. It's talking about a mathematical expression. It's an addition expression. So an expression isn't just the symbol, it's the numbers as well. So for example, there is the sum of 5 and 3. Or it could also refer to that expression's simplified, what GED students often refer to as the answer. You'll not hear me call it an answer. You'll hear me call it simplified, but I will make a nod to the fact that students will often call it the answer. So it's a simplified answer. So the sum of 5 and 3 is 8. So I could use the word sum to refer to that, what you think of as the problem, 5 plus 3, or what you think of as the answer, 8. but it would not just refer to a plus sign. Do you know the word for a subtraction expression? An addition expression is known as a sum. A subtraction expression is known as difference. Okay, guys, sorry, I had a little technical difficulty. We lost our screen, but we're back. Okay, so we are talking about the difference. So what does the word difference mean? When mathematicians use the word difference, we mean a subtraction expression. Can I squeeze in the word expression? I think I can. So for example, 8 minus 5 is a subtraction expression. Or, and here's something super important to the GED. In fact, I can't emphasize this enough. It's positive simplified answer. What the heck is Kate talking about? Positive. Well, David, do you have your GED calculator on you today?
No, I do not.
Okay. Do you have any calculator like on your phone?
Yeah.
Do me a favor. I want you to do 8 minus 5, 3. But then what if I did it the other way around? What if I did 5 minus 8?
It'd be -3.
Exactly. But when you talk about difference, what's the difference between? It doesn't make any sense for difference to be negative. Like the difference is just the size. Like, let me just draw you a picture over here. You don't need to put this in your notes. But for example, you know, if this was 5 tall, and this was 8 tall, the difference is like this little piece that one has and the other one doesn't have. And
Yeah.
it doesn't really matter if you're talking about the difference between 5 and 8 or the difference between 8 and 5. That's still a 3-unit difference. Does that make sense?
Yes.
That's super duper important to the GED, and the thing you're most likely to forget about today's lecture, so highlight it, circle it. Difference is always positive. In fact, a lot of math teachers and also the GED answers will show difference like this. It's easy enough when I have numbers to make sure my answer is positive. I'll just put the bigger number first. So like if I wanted to know the difference between 3 and 11, I'd just go 11 minus 3. But if I don't know what the numbers are, like they're A and B, I don't know what they are, I would need a mathematical symbol that says whatever answer you get, make it be positive. That mathematical symbol is known as absolute value bars. So take a look at the expression I just wrote. It says the absolute value of A minus B. What does that say? Well, what it says is that first subtract your two numbers. Take A and minus B. But because I'm admitting I don't know if A is bigger or B is bigger, when you're done subtracting your two numbers, make your answer positive. That's all those bars mean. Those bars right there, absolute value bars as we call them, mean make whatever answer you get positive. And just here's a helpful hint to everybody watching. The first 5 problems of the GED frequently feature a distance or absolute value application problem. So you will probably see those bars. I need you not to freak out when you do. It means whatever answer you get, make it be positive. A subtraction expression or its positive simplified answer. And we see 2 subtraction expressions up there. So the difference between 5 and 8, I never finished my statement, is 3. Mad at me, are you good with sum and difference? Does that make sense, David?
Yes.
Okay, so then if there is a word for an addition expression and a subtraction expression, guess what? We've got words for multiplication expressions and division expressions, but these ones usually students are not as familiar with. GED knows that, expect them to come up. The one for multiplication is a product. A product is a multiplication expression. So here is the product of 3 and 8. Or I could do the product of X and Y. Now I just said the product of X and Y, meaning X and Y are multiplying, but I didn't write any symbol for multiply. David, do you remember why I just shoved X and Y together?
It's because of how close they are.
Yeah, exactly. When they're close, they are multiplying. So that says the product of X and Y. Or it could be the simplified expression, what you guys think of as the answer. Again, I can't stress enough that to a mathematician, that's not the answer. That's just the simplified expression. We just made the same exact expression a little simpler. But for example, the product of 3 and 8 is 24. So I could refer to 24 as the product as well. Okay, cool. And so I told David, but I'll tell the rest of the internet now that I very frequently see this in algebra. I wouldn't be the least bit surprised if the GED test asked you find the sum of x plus 1 and x plus 3, or find the product of x plus 1 and x plus 3. And if you don't know those words, you won't know what they're telling you to do. Okay, super important. We have products, and the last word, do you happen to know the word for a division expression?
Yeah, quotient.
Yeah, it looks, as soon as I started writing the Q, it usually jogs people's memory. So a quotient is a division expression, or its simplified answer. Okay, so for example, there is the quotient of 24 and 3. There is the quotient of x and y. And then, of course, I could say 8 quotient of 24 and 3. The answer could also be referred to, or what you think of as the answer, as the quotient. So you need to know these 4 words for translating algebraic expressions, which is always tested on the GED. It just will be. Now that we got that down, I want to talk about it from the other point of view, from the interpreting word problems point of view, the other big skill on the GED besides algebra, looking at word problems. So in order to know when to add, when to subtract, when to multiply, and when to divide, you have to understand what those operations mean, which is not the same as how to do them. I've never met a student yet that I had to teach how to add, but I've met plenty of students who had no idea what they were doing or why. And so they'd have a problem that perhaps had some more complex numbers, and they'd have no idea that they should add. Okay, so let's talk about not how to add, but what is addition. So David, I'm going to ask you a weird question that students never know how to answer. What are you doing when you add? What is addition?
You're making one number greater than another by adding more numbers to it.
You know, that's just the answer I was fishing for, because that is a false assumption that students make. You guys assume that adding means making greater because you guys are used to whole numbers. However, just an FYI, I could show you an addition expression where the numbers did not get larger. If I took -5 and I added -4, my number would get smaller, and yet I've still added. So clearly we've got an incomplete understanding of what addition is. Just keep thinking about this for me while I keep erasing. What do you think it means then to add? If it's not to make something larger, what is it? Yeah, we do it all day long, but what does it mean to add? Okay, so what it means to add is to combine groups. Quite literally, it's to combine groups to find a total. So let's put that down. So we're talking about addition by definition. When we're adding, we're combining any size group. You know, for example, we're just putting things together. We're just putting, and the groups could be any size. You know, I could have a group of 5 and a group of 11. Put them together, boom, I've added. I can have a group of 34 and a group of 82. Put them together, boom, I've added. And David's like, well, yeah, but every time you add, Kate, it got bigger. Well, what if I had, you know, could I put together my money I have with my debt? Yes, I could. I could have $55 and I could owe $62. I could still combine that. That would be an active addition. And yet I would see my bank account drop because I just put that debt on in. Yeah. Does that make sense?
Yeah.
Okay, so we're combining any sized groups there. We're putting groups together and we don't care about the size. Okay, wonderful. Then now we need to think, it's super important, you know, your elementary school taught you the operations that she did in the certain order that she did for a reason, even if you didn't understand her reasoning. Okay, so the first thing we taught you to do, you know, we put together Johnny's and Jimmy's candies, 5 candies and 4 candies. We added them together. But then the next thing she taught you to do was to reach back in to the total and pull out Jimmy's piece, to undo addition. Super important you give me an arrow right here. The opposite of addition is subtraction. The mathematical word for opposite operations is inverse. If you don't understand inverses, you can't do algebra. Algebra is just the ability to work forwards or backwards. Okay, so we need to understand that the opposite or backwards of addition is subtraction. So then what does it mean to subtract? What am I doing when I subtract? I am removing a group from a total. Wonderful. Now let's go over to the idea of multiplication then. You know, there's actually lots of ways to think about multiplication. And the problem is you guys only have this really elementary understanding of it, kind of like with addition, and it leads you to make some super false assumptions when we get to fractions and when we get to decimals. Okay, so, you know, a lot of times I ask students what it means to multiply, and they tell me, much like you did with addition, it means to get bigger. And yet I know how to multiply things that actually get smaller. So you don't need to put this in your notes, but really quickly, if we have a calculator, let's try these. Some numbers, yes, when I multiply, they get bigger. For example, if I were to do 10 times 3, I'd get
30.
But just because I'm multiplying doesn't mean things will get bigger. For example, 10 times 0.5. Type that into your calculator. 10 is not going to get bigger. 10 times 0.5 would give me only 5. There's other numbers I could multiply and it would not get bigger. If you were to type that into your calculator, 10 times 1/10, you'd get only 1. It would get a lot smaller. Okay, so it has nothing to do with getting bigger or smaller, but what is it? What does it mean to multiply? Well, there's a few different ways to think of it. The first way is that really simple elementary school way that we were talking about in the beginning of this lesson. I said to you, you know, every student in the class has 5 candies. There are 30 students in the class. And you told me that you would multiply. Why, David?
No, it's just easier.
It's just easier than what? Then what?
Adding.
What would be another way to solve that problem or to simplify that expression?
By adding it?
By adding. I could have added the number 5. 5 plus 5 plus 5 plus 5 plus 5 plus 5. Oh my gosh, I have to not have 30 students in the class. My hand hurts. Let's say there were only 6 students in the class. Okay, 6 students with 5 candies each. I could add up the number 5 6 times. That's the long, slow way. Or I could just write, of course, 5 times 6. So one way to think about multiplication is repeated addition. Now that's the easy way. That's the way students are good with. They're like, yeah, Kate, I know that because I always forget my times tables and then I have to add real quick. I'm like, good for you. I'm glad you know it. Okay, but it doesn't do us well for a problem like this. How do you draw 1/3, 1/2 of a time? I'm just saying that this conception of it, repeated addition, would be really hard because I don't have a whole number of times to repeat the addition. I can't write like 1/3, 1/2 of a time. It's just not good conceptually this way. Does that make sense?
Yes.
So I need more of a deeper understanding of what it means to add. That's all I'm saying. We'll talk about multiplying fractions another day. Okie dokie. Okay, so that being said though, what is another way to conceptualize multiplication? Well, another way is putting together same-sized groups. So it reminds me very much of the last one, you know, addition. In addition, we were combining any sized group though, and here we're putting together same-sized groups. If it's multiplying, all the groups need to be the same size in order for multiplication to work. Or thirdly, and this is the one most important to the GED, so, and also the one that students are least likely to know, so highlight it, underline it, now's the time to pay attention if you've been bored. Scaling. Multiplication is an act of scaling. David, have you ever heard the word scaling before? I bet you have, because you have construction industry, right?
Yeah.
I'm actually talking about scaling something's size. Do you know what I mean when I say I'm going to scale its size? Scaling a size is like what we do on blueprints or maps. Scaling a size means, you know, taking the dimensions and either you could pull them out bigger, like when you build a house off of the blueprints, or you can pull in dimensions smaller, like when you make the blueprints based on the house size.
Yeah.
Okay, so scaling is this idea that it can make numbers both bigger and smaller. And so that's a much better understanding of multiplication for us than this more elementary level of just repeated addition or putting together same size groups, because we're going to work with all different kinds of numbers on the GED. We need to understand that multiplication is an act of scaling. So let me show you what I mean. So for example, I could scale 10 up 4 times larger. So if I made 10, like maybe 10 inches 4 times as large, I would get
40.
Or I could scale 10 smaller. I could make 10 half as big. If I made 10 half as big, what would I get? Don't panic about the fraction. Just tell me what you'd get if you had got half of 10.
5.
And why were you panicking? You were going, I don't know how to multiply fractions. Yeah, I didn't have to know anything about multiplying fractions to do that. I just had to understand that multiplication was an act of scaling. I can take a 10 and I can make it half as big. I can make it 10 and I can make it 4 times as big. Now, do you understand then what I mean by an active scaling?
Yep.
So I'll just write it in mathematical terms. I'm talking about increasing or decreasing the size of a number by a scale factor, by a certain, and it could be, again, a larger factor or a smaller factor. Okay, so those are my definitions for multiplication. So then I ought to be able to take a look. If I can multiply, I ought to be able to do the opposite. I ought to be able to divide. So once again, we have this concept of inverses. The inverse of multiply is divide. It's the opposite. So that means that if I can call multiplication repeated addition, do you know what? One way I can think about division is repeated subtraction. Now that blows a lot of students' minds. What? Repeated subtraction? Well, let me show you what I mean. If I say, I'm going to do a really easy one, and I don't care where you write this. I don't need this in my final notes, but I'm going to just do an example of how 15 divided by 3 can be viewed as repeated subtraction. What am I asking you there? I'm asking you, how many times can you take 3 out of 15? How many times can you take 3 out of 15? How many 3s are in 15? Well, I could just repeatedly subtract. I could take a 3 out, I'd get 12. Then I could take another 3 out, I'd get 9. Then I could take another 3 out of that 9, I'd get 6. I could take another 3 out. Now this is not the way most of us divide because it's kind of the long way. Take another 3 out. And you see now I have nothing left. I used up my 15. Does that make sense?
Yep.
Well, how many 3s did I just take out?
5.
1, 2, 3, 4, 5. 15 divided by 3 is 5 because I had to subtract 3 5 times. It's repeated subtraction. Now that would be the long way to do it. But by the way, if there's anybody in this listening to this video, I don't think David is this type, but if there's anybody who's ever struggled with long division. Long division is the only video I've ever made that's gone viral, I think, because so many people struggle with it. There's another way to do division. Long division is not the only way. I have a way, you should go check out a video called partial quotient division, which is based on this idea that division is just repeated subtraction, okay? So that's one way to envision it. Let's think of another way. We said that one of the definitions of multiplication is putting together same-sized groups, putting together same-sized groups to make a total. So then how could I envision division as the opposite of that? Well, division would be taking that total and breaking it back into those same-sized groups. Okay, and then finally, am I going to relate it to scaling? Increasing or decreasing a number by a factor? I don't think I am. Look at me, breaking my own rules. It's not a real clear connection, and I just don't feel to confuse anybody. So I'm just going to leave that there with division for now. So then I'm going to show you some example problems. Now, for once, I didn't make an example problem thing, so I'm just going to throw it up on the screen. But I just want to let you know that, man, the examples for this, I could come up with 150 different applications here. I mean, I really could. Okay, but I'll just share a few with you that are super important to the GED, okay? So with what we've learned today, you know, one of the most important things, skills that you need for the GED is just being able to read the language of algebra. Okay, for example, here is a typical expression that you might be asked to simplify on the first 5 problems of the GED. Now, if you're looking for me to simplify this whole thing, I'm not going to do it today, but I just want to show you an application of what we did today. I want you, David, to be able to read to me what this sucker says. Now, what does this say? What are these numbers doing? If you can't read the operands, the number symbols, you won't know what to do. You won't know how to read the mathematical instructions. Does that make sense? So let's just go ahead and read this together. Of course, this part's easy. I have 2. But what is this 2 doing if it's shoved against this parentheses?
It's multiplying by 5.
So I read 2 times the quantity of 5 minus 3. Is that good? Does that make sense?
Yep.
And then it's all over. Well, what did we say it meant if it was over something?
It's dividing.
Yes, divided by, and then of course this is just 6 minus 4. So 1, you just have to know how to read those symbols to know what the problems are asking you to do. Make sense?
Yes.
Okay, so really quickly, let's just review. What does that say, David?
It's going to be 2 times 5.
Beautiful. And that?
6 divided by 2.
Awesome. And that?
X times Y.
Beautiful. Proximity means multiplication. Glorious. Now this one's a little hard to read, okay? But I do need you to see that this entire ugly thing and this entire ugly thing are doing what?
It's X minus 1 times X minus 3.
Yeah, except for I would say the quantity. So I know that you mean the whole thing. The quantity of X minus 1 times the quantity of X minus 3. Wonderful. Is that good?
Yep.
Okay, cool. So that's one context you need it for. But the other context you need it for, and this is where a lot of students mess up, is writing algebraic expressions. So you will definitely have problems where you either have to write algebraic expressions, equations, or inequalities. Expressions are the easiest, so this is our first muck into this. But the GED might say something to you like, translate into an algebraic expression, probably say translate the following, I'm being a little lazy. And then they'd give you some words like about twice the sum of 5 and 8. Twice the sum of 5 and 8. That's weird. Let's start with this phrase, which is how it relates to today's stuff. We just talked about the sum of 5 and 8. What does that mean?
It's adding 5 and 8.
It is 5 plus 8. But notice, I don't just want the sum of 5 and 8. I want twice that. If I use the phrase twice, what am I trying to say?
You're multiplying.
Yeah, how many times?
Twice, 2 times.
2 times. So I want that whole thing, the whole sum, multiplying twice. 2 times that whole sum. Notice I use parentheses so it can multiply by the whole sum. And that's why I say it's so important to understand that the sum is not just the plus sign, it's that entire expression. Okay, I'm not going to do a ton more problems with you. The other application of this, which would be number 3, is interpreting word problems. So don't worry, guys. It's not that I just forgot about doing this application in this video. We are going to be looking at interpreting word problems for our entire next unit. I know it's a unit that a lot of students struggle with, and so that's what we're going to have coming up. And the very first lesson I'm going to do as part of that unit is choosing the correct operation. So look for that in the next couple of weeks. Thank you for joining us in virtual GED class today. I realize there weren't a lot of example problems today. Why? Because these are the basics we need in order to be able to do a ton of other things. So let's look at the first new application of this today, or next class, I mean. Next class, we're going to be looking at a new operation, exponents. And we are going to relate that to what we've done today. Super important. There's exponents all over the GED, so you definitely need to understand them. So join us next week.